Hey everyone, in this video we're going to be solving a quadratic equation in intercept form using something called the zero product property. Sounds intimidating. It's a teddy bear, trust me. So looking at this graph, we know we're trying to find the solutions. When we say solve a quadratic, we mean find the solutions, which is the roots, the x-intercepts, the zeros. And then in this case it's x equals 1 and x equals 5. We also know that intercept form, which is a times x minus p, x minus q, that our x-intercepts are just p and q. So this seems like a very, very trivial thing to find, but what we're going to look at is there are some complications we can put inside of here that can make this a little bit more difficult and make the zero product property something that's handy to have in our back pockets, not products. So looking at some examples to show you where the zero product property comes from. Let's just look at evaluating these expressions. So 5 times 0. Well, it's 0. 349 times 0. There's a little more going on there number-wise, but if you didn't know, you can put it into a calculator, and it turns out it's 0. Sine of x plus the tangent of 3y minus 9 times 0, even though I don't know what x is and I don't know what y is and you don't know what sine is or tangent, it turns out this is still equal to 0, because anytime you multiply a number by 0, your answer is always 0. So we can take advantage of this with the zero product property that tells us if an expression contains multiplication and evaluates to 0, one of those factors is equal to 0. And so we can go back to our original equation and we can figure out why p and q are my roots, my x-intercepts. So looking at this, I can see that this is equal to 0 because when I solve a quadratic, I always want to solve it set equal to 0. That's one of the first things we talked about in our very first video. So since when I multiply these three things together, there's 1, 2, this whole term, and 3. I multiply these three things together and I get 0. One of those things has to equal 0. So it could be that 2 equals 0, except, well, that's kind of nonsense. We know that that's not the case. So it could be that x minus 1 is equal to 0, or it could be that x minus 5 is equal to 0. Well, if x minus 1 is equal to 0 and I want to find out what x is, I just add 1 to both sides and I get x equals 1. That's one of my solutions. And over here, I would add 5 to both sides and x equals 5. And that's my other solution. And there it is. The reason that p and q are going to be my solutions is because I'm taking the fact that either that is equal to 0 or that is equal to 0. And now that I have this, I can solve any kind of problem I want to that way. So let's look at some examples. Suppose I have 5m times 7m minus 9 equals 0. Well, those equal 0 when I multiply them together. So there are two options here. Either 5m is equal to 0 or 7m minus 9 is equal to 0. One of those two things has to be true, and I can figure out what m is by solving both of these. So here I'm multiplying by 5, so I'm going to divide by 5 on both sides. 0 divided by 5 is 0. So one of my solutions is going to be that m is equal to 0. Over here, I can add 9 to both sides, and I would find that 7m is equal to 9. And then I can divide by 7. And notice this gives me kind of an ugly fraction. Ugly fractions are okay. They're people too. They need love. So I can say that m is just 9 over 7, and I can just leave it as a fraction. There's nothing wrong with that. And now I've found my two solutions by setting each one of those factors equal to 0. Easy as that. So let's look at another. I could have, in this case, either n minus 4 or 3n plus 7. is equal to 0, I know it's not going to be 3 because common sense tells me that 3 is not equal to 0. So I don't have to worry about that so much. But I could say that this factor is equal to 0, or this factor is equal to 0. And now all I have to do is solve like we know how to do. I'm going to add 4 to both sides over here, and it could be that n is equal to 4. Don't you just love random color changes? And over here, I could subtract 7 from both sides, and I get 3n equals -7. Divide by 3, and I find that n is -7 over 3. So those are my two solutions right there. Either n equals 4 or n equals -7/3. You can look at this one, and there are no more ways to do this. Take each one of the factors, could be equal to 0. It's not going to be -4. So I can say 2n minus 1 is equal to 0, or n plus 6 is equal to 0, and now I just solve. So I can add 1 to both sides. I get 2n is equal to 1. Divide both sides by 2. So n could be 1/2. That's one of my solutions. Over here, subtract 6 from both sides. Or n could be -6. That's the other. So friends and neighbors, there you go. That is the zero product property. You are now ready to solve any quadratic equation you see in intercept form. Good luck.